In this video, I'm going to talk about vertical and horizontal asymptotes. I'll talk about these asymptotes using two functions. So let's consider the first function f of x, I guess, is equal to 1 over x minus 5 maybe. Okay. So this function has asymptote, but it's a vertical asymptote at x equal to 5. At x equal to 5, what happens is this. So let's try to sketch it. So this is your x and this is your y. So at x equal to 5, so let's say x equal to 5, you could approach 5 from the right hand side. If you approach 5 from the right hand side, what's going to happen? Let's say the function looks something like this, and it goes towards infinity. And if you approach from the left hand side, it's gonna go approach to the negative infinity. You can try out some numbers, like you could try something like 5.1, 5.01, 5.001, etc., and you will see that the denominator becomes extremely small from the positive side. That means it's a positive number but very, very small, so it becomes it goes towards positive infinity. And similarly, from the left hand side, if you're approaching 5, the x minus 5, so you could try values of x is equal to 4.9 or 4.99 and or 4.999, etc. Okay, and you will see all the numbers in the denominator here are going to be negative, very closer to 0, and 1 over that number becomes extremely small or extremely going towards negative direction. So it goes towards negative infinity. So you have a situation where you have a vertical asymptote at x equal to 5. Similarly, for a function, if I generalize this idea, a function has vertical asymptote at x equal to a if limit x approaches a, f of x is equal to infinity. This could be plus or minus infinity, so I'm just going to put plus or minus. For the horizontal asymptote, let me consider a function g of x. Okay, g of x is equal to maybe 1 over e to the power x or e to the power negative x, 1 over e to the power x plus 5. Now let's investigate the behavior of this function. What happens to g of x as x goes towards infinity? As x goes towards infinity, 1 over e to the power x becomes really, really, really small, right? Or in the limiting case, this becomes 0. So we are left with nothing but 5. So if you were to sketch this function, okay, x and y, it's going to look like this. Let me just do this first to help you out. So e to the power negative x, by the way, looks like this. It's an exponential decay, right? So it's going to look something like this. So I said e to the power negative x. By the way, e to the power negative x is the same as 1 over e to the power x. Just a reminder. So this is just 1 over e to the power x or e to the power negative x. So if we add 5 to it, what it's going to do is going to take this and move it up by 5 units. So let's say this is up by 5 units. It's the same function. Okay. This is where it's going to be. And the line y is equal to 5 is going to be right here. Okay, as x goes towards infinity, this e to the power 1 over e to the power x plus 5 is going to approach the line 5, y is equal to 5. So you have a horizontal asymptote here. Now, if I were to kind of generalize this idea for general situation for horizontal asymptote, so you're going to get limit x approaches infinity, f of x approaches some value, let's call it b. So now at y is equal to b, we have a horizontal asymptote. asymptote. Okay. So these are kind of the rules for vertical and horizontal asymptote. To summarize, limit x approaches some particular value f of x is equal to infinity plus or minus, that will indicate the presence of a vertical asymptote. On the other hand, limit x approaches infinity, I meant to say g of x here, guys, g of x, because just to be consistent. Limit x approaches infinity, g of x is equal to some value b constant, means that y is equal to b is a horizontal asymptote. I hope that this discussion was helpful. Thank you very much.